Okie dokie. In this problem, they say if the function cosine of 3x is periodic, what is its period? So it very much helps for these problems to understand that for sine and cosine functions, the period you will find by doing 2 pi over b, where b is the coefficient of the x term. So sine of bx or cosine of bx, whatever number is attached to x is your b. Okay, so to find the period, all we do for this one is 2 pi over b, which is 3. It just comes from the number that's attached to the x, and we don't have to simplify that. It's just 2 pi over 3, and we're done. Pretty cool. Let's do like 4 more here. Here we have sine of x over 3. So again, for sine and cosine, the period is 2 pi over b. So what's b in this case? What number is attached to x? If you were to rewrite this, 1/3 x. I know sometimes x over 3 might look a little confusing, but maybe it looks a little nicer in this format so you can tell what b is a little bit easier. So to find the period, we will do 2 pi over 1/3. If we're dividing by a fraction, we can multiply the numerator here by its reciprocal. So 2 pi times 3 over 1. 2 pi times 3 is 6 pi. Over 1 just, keeps it 6 pi. So the period is 6 pi. Hope that makes sense. Let's keep going. Yeah, we have sine and cosine, both of x over 2. So no need to do anything crazy with this one. Again, since sine and cosine kind of have that same formula for their period, we can just use that same formula with one of the b values. You don't need to do anything fancy like multiplying by 2 or dividing by 2 or anything like that. We're just going to still divide it by b from either one of them, so sine or cosine here. So the b value, if we were to rewrite this, we could call it 1/2 x instead of x over 2. So that means b is equal to 1/2. If we're taking 2 pi and dividing it by 1/2, that's the same as multiplying 2 pi by 2 over 1, or just 2, for a result of 4 pi. Break out the eraser to see that C is our answer. Now let's get a little different here. I've only addressed sine and cosine. Sine and cosine's periods being 2 pi over b. Now, anytime you see cotangent or tangent, so tan or cotan, it's important to know that their period is originally pi, and so their formula for calculating any period would be pi over b instead of 2 pi over b. Okay, so keep that in mind for tangent and cotangent. So now, our b value in this case, hopefully it's clear to see that it's 1/3 based on the past couple problems. So we just take pi divided by 1/3. Dividing by 1/3 is the same as multiplying by 3 over 1, or just by 3. So pi times 3 is 3 pi. All right, let's do one more. All right, this is the Mama Jamma. So what I also have not addressed is, along with sine and cosine, since those periods are 2 pi over b, their inverses, cosecant and secant, will also have that same period, 2 pi over b. Sorry, I'm just addressing it. I just thought about it when I saw this. So 2 pi over b for secant and cosecant, but cotan will still be pi over b. So the question is, which one do we use in this case? Well, let's find both of them, and then I'll talk a little bit more about which one we'll use, I guess. So cotangent, we want to use the period equals pi over b, and b is 2 in this case, right? So our period is just pi over 2 for that. And then for secant, that uses 2 pi over 2, which is equivalent to just pi. So the question is, do we use a period of pi, or do we use the period of pi over 2? Well, think about it like this. If it's going to take secant a whole period of pi to complete a cycle, then there's no way that the sum of these two could complete a cycle any faster than pi. There's no way we would call the period of this whole thing pi over 2, because the secant piece hasn't yet completed its period. It's going to complete its period once it reaches a full, value of pi. Does that make sense? So you always want to go with the larger value, the larger period of the two, because, if it takes pi for the secant piece to complete a cycle, and cotangent it only takes pi over 2, well, at least cotangent will also be able to complete a second cycle. Like it'll be, I guess like it'll take pi over 2 for the first cycle, and then once it adds another pi over 2, it'll get to pi. it'll get to pi, and it'll be a second cycle. I don't know. The cycles overlap right at pi. I don't know. Go with the larger value. You get what I'm trying to say, hopefully. Go with the larger value of the period of the two different periods you get, I guess. All right. Hope that makes sense. Here's 5 examples. If you have any questions, you let me know.